Melissa is a biomaterials scientist and biomimicry innovator, and also a Marie Sklodowska-Curie Fellow. So I will now pass it on to you, Melissa. You have 2 minutes whenever you're ready.
Sure, thank you. Thank you for the invitation today. I'm really happy to be here. So maybe a little bit about my background and how I ended up in so many different fields. So I do have the scientific backing in the sense that I have a biomaterials background and a PhD in that, particularly looking at biomimicry. I also have a master's in environmental process engineering, and it was through that experience that I started to realize there was a gap between the technologies that engineers were developing, or at least we were developing in thesis form. I was a researcher at that time, and what actually can be applied. So I became interested in human-centered design and sociology and cultural context and how that affects technologies that we design. And that slowly crept me into the field of biomimicry. So now I've been a biomimicry specialist for about 13 years. And for those of you who don't know what biomimicry is, it is looking to nature as a model and a mentor for solutions. So they are kind of trusted examples that people may know, kind of looking at the termite mound and how that has special ways of regulating temperature. And some architects have emulated that in buildings and housing. And there's an example of a mall in Eastgate in Harare from my home country in Zimbabwe, for example. But there have been a lot of examples that are around biomimetics and technology in the biomedical field as well. But what we started to look at as Learn Biomimicry, so I'm an educator in Learn Biomimicry, where we provide biomimicry tools and creative tools for people at an affordable price to learn the biomimicry method, because you can also find solutions to how we can organize ourselves in society. So looking at ecosystems, how species coordinate and cooperate, how we can look at swarm intelligence in bees for AI, but also looking at semi-democratic systems in African wild dogs, for example. We had one of our learners look at that for policy making. So yeah, I'm in this biomimicry field and happy to share a little bit more later on.
Yeah, thank you so much, Melissa. It's really nice to hear about such a innovative and unique field of research that not many people might notice is around us. And for everybody to learn about how we can learn from nature for applying things in everyday objects or processes.
So, Melissa, your work in biomimicry draws inspiration from natural systems. How can nature-inspired innovation help us design solutions that address climate change, reduce waste, and improve access to essential resources like water?
Sure. Thank you for that question. I think it's quite a broad question, but maybe I can speak to what we try to teach in biomimicry and then go from there. So there are three C's of biomimicry, which is to reconnect, emulate, and ethos. And I think people often forget the ethos, but Marie spoke about ethics as well. So in the reconnect, it is going outside, looking at nature, looking at systems, and kind of looking to nature as a mentor. And what that does for us is that, okay, nature has about 3.8 billion years of R&D. And, it clearly has done something right in those 3.8 billion years. And it takes the pressure off of us to be innovative and just kind of remember the connection with nature. So reconnect is the first part of biomimicry. And the second one is emulate, which is the biomimetics. It's the technology that comes around looking at forms and functions and processes and systems in nature and how to extract that. So part of what we do in Learn Biomimicry is teach people this translation step. How do you become a biomimicry practitioner? How do you find these patterns? How do you translate that from our world with our human nouns? For example, you can't come in with the question, how does nature air condition? That's something in our built environment. It doesn't happen in nature. And then you need to start to think in biological terms, such as how does nature regulate temperature? And then you start to really see some solutions that you can find within different environments. Are we regulating temperature in a desert? Are we regulating temperature in a cold climate between 2 degrees or 10 degrees? So we give people these tools of how to learn while reconnecting nature to see these patterns. And the last one is ethos. where it really is, how do we do this ethically? How do we make sure we use clean energy, clean materials, and really respect the knowledge generation of First Nations as well? Biomimicry is not anything new. It is something that was also already emulated in past societies as well. Yep.
Thanks, Melissa. That's really great. We connect immediately those, and I get it. I get the fact, the patterning, understand pattern. What hit me is how does nature regulate temperature, like the how, and then you now start from there. That's really great. Thank you. You focus on creating solutions that are accessible across diverse contexts. How can innovation be designed intentionally to support underserved communities and contribute to poverty reduction and equitable development?
Yeah, thanks for that. I can think of it in kind of how I've tried to approach a few research questions in my work. The one is around cultural and social acceptance of technologies, and I spoke to that earlier. That was kind of the first question I had around how do we get sustainable technologies out in restricted areas and in economies and emerging economies. Maybe I can give an example, a project I worked on, which was making fertilizers from human waste. This is not a new technology. It's been accepted or socially accepted and been done in various parts of the world. But I particularly wanted to try this in South Africa, and I did the research and understanding the technology that can be used there. And then after 2 years, we realized what we had proposed failed because the community we were trying to give this solution to were not farmers. We were providing the benefit of fertilizers, but they had no real use for it. But also in that community, a flushing water toilet is a status symbol as well. And we were coming in with toilets, separating and composting toilets to push our sustainability agenda. So we didn't really involve the community at the time in our decision making. And I think that's vital to start in understanding the status symbols, the cultural acceptance, and design technologies backwards, and how to communicate and translate that to engineers. And another question I've had recently is, what if the technologies that we need to solve a lot of our kind of wicked problems already exist? Maybe they're just being used in different contexts. And how can we get translators and people who are able to look at these technologies in different disciplines and different fields and can be translated to another use? That's what I did with my PhD. Actually, I was looking at water treatment, and I looked at surface coatings that are typically used in biomedical devices and try to see if I could translate that for water treatment in low-income settings and whether that would work. So that's kind of a question I'm interested in at the moment. What if they exist and we just need to translate them across fields?
Thanks for that, Melissa. That's really great. So involving communities decision making is key. And then knowing how to translate it, how to use already existing technologies, how to apply that in communities. Your work emphasizes collaboration across fields. Why is interdisciplinary thinking critical for innovation? And how does it enable more effective responses to complex global challenges?
I think this accumulation of what everyone's been speaking about, I think, answers this in a way. We really need that transdisciplinary or that interdisciplinary collaboration between different fields. The example I spoke about, in the sense that I try to, look at the biomedical field and some of that technology to solve problems in the water field, for example. But that could only be done if I was able to communicate with a biologist and a biomaterial scientist and an engineer, which is my background. And maybe I can use a metaphor here as well, which we tend to do a lot in biomimicry. So an ecotone is kind of this barrier between two different climates and two different ecosystems. So a beach is an ecotone, a swamp is an ecotone as well. And these are places of great tension because you're going from water to land, for example, but they're the most fertile, biodiverse areas in ecosystems in general, because there's so many different species mixing and mingling. So that kind of between different fields, different disciplines, that's where ideas come from, where different ecotones are built. And I feel our education systems, I think, Omar, you're working towards this, need to start really kind of reinventing itself. What if we didn't have these specializations, but people could study problem solving just in general? So that's what biomimicry students do, and that's what biomimicry professionals do. They have to translate from one field to another, but also to build a solution. They have to talk to a material scientist, a biologist, a chemist, and to be able to understand all those different languages and translations. So yeah, I'm really hoping this field of biomimicry and translation and interdisciplinary design makes sense for the future. And I think it does.
Thanks, Melissa. So yes, it's everybody, it's a collaboration of everybody. Like you said, biomimicry, it's understanding all the different, bringing all the different experts, right? In order to come up with the best way to implement, nature, in life. So that's really great. Thank you.